This is Alberta Hemsley of Withrow International High School in Cincinnati, Ohio. Today we're going to talk about grams and the triple beam balance. The first thing you need to notice is that it has 3 beams, each of which has a metal weight on it. We will call the weights riders. The first thing we need to do when we come to the triple beam is to zero it in. We do this by moving all of the weights to 0. If the pointer goes a little bit below the 0, it's too heavy. If the pointer goes above the 0, it's too light. We want the pointer just at 0. We've moved all of the weights to 0. Now we need to fine-tune. We do that by finding the knob. Here's the knob to the left and underneath the pan. We're going to turn the knob and turn it back and forth until we get it just at 0. When we're weighing something, the riders need to be in the notches. They cannot be between the notches. When the rider is in place, you can feel it being in the notch, and you will see the point on the rider to the correct number. When you start weighing on the triple beam, you will always start with the largest rider first. In this case, we will start with the hundreds, and then we will go to the tens. The tens beam has notches also, and you will notice that when the rider is in place, that the pointer on the rider points to the desired number. The last beam of the triple beam has no notches. This rider just slides. This last beam is read to 2 decimal places. This one will probably be 1.33. This rider is reading 2.11. Here is a new nickel from 1999. This value of the nickel is something like 5.11. Be careful to read the values from straight on. This value is being read from the side, and it looks like 5.19. Read straight on, 5.11. The U.S. Mint has been known to change the materials that it makes its coins with. Let's see if this is true of the nickel. Here we have an old nickel, 1963. The old nickel seems to weigh just about the same, 5.11. We can use the nickel, 5 cents, as something to help us remember what 5 grams feels like. Just how sensitive is this triple beam? Let's weigh a little post-it note. It seems to weigh 0.59 grams. How about a smaller post-it note? What does that weigh? The small post-it seems to weigh 0.10 grams, 1/10 of a gram. What about this 1985 quarter? What does it weigh? Here the value is too light. Here the value is too heavy. When the rider is at the correct weight, it weighs 5.83, not that much more than the nickel. What about a newer quarter, 2004? This newer quarter, seems to weigh 5.84. The new and old quarters seem to be about the same. Here's a new dime from 2000. 2.34 grams. And the old dime, 1969, 2.35, about the same. Let's weigh a small paperclip. Not the large paperclip. The small paperclip weighs just half a gram, 0.5 grams. We can do the math and say that 2 little paperclips is 1 gram. Let's weigh this little Plavix pill that has a 75 on it. The bottle says 75 milligrams. What does that mean? Well, the one little pill alone seems to weigh 0.3 grams. That's about 300 milligrams. What's going on? Let's look at the label. It looks like there's 75 milligrams of what we want and 225 grams of something else. Let's do milligrams for a moment. 0.1 grams is 100 milligrams. 0.30 grams would be 300 milligrams. 0.80 grams would be 800 milligrams. And finally, 1.00 grams would be 1,000 milligrams. Just how many grams can this scale weigh? Let's add them up. 500 plus 100 plus 10 is 610. 610 grams is a little more than 1 pound. Let's weigh something a little more challenging, say a cell phone. We try 100 grams, and that's too light. We move the ryder to 200 grams, and that's too heavy. So we move the ryder back to the 100 grams, and now we're trying the tens. Move the tens ryder back to 0, and now we're back at 100, and then we move the last ryder. We slide this last ryder over to 3.18. My cell phone weighs a little more than 100 grams. Let's try something even heavier. This soda contains 355 milliliters of some liquid. We start at 0. 400 grams was too much, so we moved it back to 300. We're now trying to find this tens place. We try at 270. It's too light. We try 280. 380 is too heavy, so we go back to 370. Lastly, we get to the ones ryder, and we move it over. We slide the last ryder over to 1.86, a value of 371.86. Can we find out how much the liquid weighed inside the can? Sure, but first we have to weigh the empty can. 100 grams is too much. We move it back to 0. 20 grams is too much. We move the tens ryder back to 10. We move the ones ryder over to 4.83. We add the 10 plus 4.83. We add the values on the two beams together, 10 plus 4.83, to get 14.83. So how do we find out how much 355 milliliters weighs? We take the value of the full can, 371.86, and we will subtract the value of the empty can, 14.83, giving us 357.03. 355 and 357 must be a relationship there, but we'll find that later. Let's review. When we go to a triple beam, the first thing we do is zero in. We move the heaviest ryder first. We move to the one notch beyond where it's too heavy, and then go back to where it's one notch too light. On to the tens beam. We go to one notch too heavy, and then move it back to where it's one notch too light. Last, we move to the ones ryder, and we slide it over to where it's exactly where the pointer is on 0. We never read the last ryder from an angle, from the right or the left. We want to read it straight on. We always read 2 decimal places. This would be 5.10. This triple beam can read to about 610 grams, or about 1 pound. Our final value is the total of all of the ryders put together. And there we have it, grams and the triple beam balance. Enjoy!